Hello, this is Alexi Leeper and Cody Perry. This is our demo for Lab 5. To start out, I will talk about the initialization. These are our register definitions and variables. Something to note is that these are constants, not variables, my apologies. Something to note is that we define left and right count as register 23 and 24. These will hold the left and right counters, as you will see very soon. Just talk about the initialization. 2, 4, and 8 respectively represent pin 0, 1, and 3, as these comments indicate here. And pin 0 being hit will hit right. When pin 1 is hit left will occur. And when pin 3 is hit, clear counters will be ran. And that's it for the interrupts themselves. For the initialization, very similar to the bump bot program, we'll initialize the stack, port B for output, port D for input. Whisker right, left, and clear are going to be the 3 pins. These will be 4, 5, and 6 respectively. Then I'll initialize the LCD. I'll make sure the LCD is cleared as well as the right and left counters. Setting up the interrupts. These are the pins necessary to, or the bits necessary to set the interrupts as controls to the falling edge. I will put that in the EICRA, and then I will configure the external interrupt mask with the 3 pins that we are going to be working with, 0, 1, and 3. With that, I will build the solution. It has succeeded, and then I will reset my board. And it's good to go. As you can see, the LCD is cleared. So firstly, the main function will be perpetually moving forward until an interrupt occurs. It's constantly going through that while loop. Hit right, I'm gonna push my registers to the stack. To start out, I will disable all interrupts. This will prevent nested interrupts from occurring. And I will update my counters. I will clear the LCD for now, increasing the right counter. And after that, I will move that into NPR. And then I will point X to the start of the LCD, the first line of the LCD. And bin2 ASCII will automatically set that with the NPR and X, it will set that value to 1. And then all I have to do is write that first line. And then I'll do the same thing with the left count. I won't increment it since the left button was not pressed. And with that, we'll move backwards, turn right, just like the bump bot program. And then I will clear the queue to EIFR. 1, 0, 1, 1 are the 3 pins that we used earlier. I will output EIF, and I will output that to EIFR. And then after that, I will enable interrupts. This will prevent queuing, so if I press the same button over and over again, it won't run the interrupt multiple times until the first interrupt is complete. And I press the button after it's complete. With that, I will hand it over to Alexi Leeper to define our last 2 functions. My apologies, I forgot to demonstrate that functionality. I will press pin 4. As you can see, the top counter is going to be representative of the right. That left light LED will be going first, and then it'll start moving forward again.
And then for our hit left function, we have these pushing our registers that we're going to use within the function. And then we can enable or disable the interrupts with CLI. And then, so with our left function here, we're going to first disable the registers that we use with the function. And then here we can disable interrupts with the CLI command. And then here we're going to update the counters by first calling the LCD clear function. And then we can move the current count of the right counter into NPR. And then since we're not going to be updating the right counter here, we don't have to increment. And then we can set the X pointer to, I forgot complete. Yeah, so with our hit left function here, we start by first saving all the registers that we plan to use in this function. And then we can use the CLI command to disable interrupts and prevent any nested interrupts here. Here we can move on to updating the counters, and first we're going to move on to the right counter and not increment because we won't be updating it with this left hit function. Then we can move on and increment the left counter register, and we can point the X register here, and then we can use the LCD write line to write this new value for the left counter. And then here we can do the basic bump bot actions to change port B and display its behavior. And then here we can clear the queue for the EIFR and enable the interrupts again with SEI. And then finally we can pop all the registers from the stack and continue with the program. And then to demonstrate the left hit with the PD 4 or 5, and then clicking here, increments once, and then we can increment it a couple times to get past 10.
And as you can see, when we press the button while the bump bot behavior is happening, the counters will not increase as we have eliminated all queuing and nested interrupts.
And then we can move on to this function in the program, the clear counters function. Here we're going to be saving the registers again, and then we'll decline the CLI to disable the interrupts and prevent nested interrupts. And then we can go on here and load the value of 0 into the X pointer for the right counter. And then we can move on and load a value of 0 into the right counter. And then finally, we clear the queue for the EIFR and re-enable interrupts with the SEI command. And then finally, we can pop all the registers that we use for the function. And then to demonstrate here, we just press this button and it clears the LCD display.